Consider a spring of spring constant K, and at the end of the spring a mass M is attached. Suppose this mass is put in a medium. Let this blue region be any medium of a particular density. Suppose the mass move from left to right, that is in this direction. The different forces acting on the mass are, first one is the restoring force. Let's call that as Fr. Restoring force is towards the mean position. And since the mass is moving in a medium, there is a viscosity between this mass and the medium. So there arises a force Fb called the drag force. Fr is the, let's say, Fr is the restoring force, and Fb the drag force. Both act in the direction opposite to that of its motion. So the net force will be F net is equal to Fr restoring force plus Fb the drag force. But you know from the Hooke's law the restoring force is equal to minus kx, where x is the displacement, k the spring constant. Also we have the drag force is directly proportional to the velocity. Whatever be the velocity at the instant of its motion, drag force is always proportional to its velocity. And velocity and drag force are in opposite direction. So here also you have to put the minus sign. So Fb is equal to, in order to remove the proportionality, you have to put some constant minus b into v, where b is a constant. So you can plug in the value of Fr and Fb in here. So the net force will be F net is equal to Fr is minus kx plus minus bb. So this is equal to F net is equal to minus kx minus bb. And from the Newton's law, we have net force. Force is always mass times acceleration. This mass into acceleration A. So this is equal to minus kx minus b. And if you take all the terms to the left, and also you have A is equal to the second derivative of displacement with respect to time. So this is equal to m d square x by dt square. Taking these two terms to the left, so it will be plus kx plus b into v equal to 0. Now this can be written as, you can call this as equation number 1. If you divide this equation divided by mass with m, dividing equation 1 with mass, you will get d square x by dt square plus this is equal to k by mx. You have to divide the whole term with mass plus b by m v equal to 0. Also this is equal to d square x by dt square plus k by mx plus b by m. You know v is equal to dx by dt, the rate of change of displacement, equal to 0. And this can be rearranged as d square x by dt square plus b by m dx by dt plus k by m x is equal to 0. So this is the differential equation of in case of damping, differential equation for damping. Clear? Now we have to find the value of x. This is damping, differential equation. So we need to find the solution of x. For that, let's take two different values, or we can put a different value for the constants. That is, let's say b by m is equal to some 2 omega 1. Also, this k by m, let's put that as omega 2 square. Let's take this b by m is equal to 2 omega 1 and k by m equal to omega 2 square. If you plug in the values in here, you will get d square x by dt square plus this will be 2 omega 1 dx by dt plus k by m, you can write that as omega 2 square x is equal to 0. Let's call that as equation number 2. Now, this is in this kind of differential equation, second degree differential equation, the solution usually comes in the term of a constant into an exponential term. So let us take, let x is equal to a e raised to alpha t, where a is the amplitude, or let's now consider that as a constant. So let's plug in x is equal to a e raised to alpha t in here. So that dx by dt will be dx by dt is equal to a into a is constant, e raised to alpha t, derivative of e raised to alpha t is e raised to alpha t, times derivative of alpha t is alpha. That is a alpha e raised to alpha t. Now d square x by dt square means you have to derive this again. So a alpha into a alpha is constant, you can take that out. E raised to alpha t is equal to e raised to alpha, derivative of e raised to alpha t is e raised to alpha t into alpha. So a alpha square e raised to alpha t. So you can plug in all these values in here. So here it will be a alpha square e raised to alpha t plus 2 omega 1 a alpha e raised to alpha t plus omega 2 square x is equal to a e raised to alpha t equal to 0. Now you can take this a e raised to alpha t common. So a e raised to alpha t times alpha square plus 2 omega 1 alpha plus omega 2 square equal to 0. Now we need to find the value of alpha. So this can't be 0. Therefore the possible way is alpha square plus 2 omega 1 alpha plus omega 2 square equal to 0. This is nothing other than a quadratic equation. So the solution of this one equal to alpha equal to, this is b, that is minus 2 omega 1 plus or minus root of b square, that is 2 omega 1 square minus 4 into a is 1 into omega 2 square by 2 into a is 1. So alpha is equal to minus 2 omega 1 plus or minus, this is equal to 4 omega 1 square minus 4 omega 2 square divided by 2. So alpha will be minus 2 omega 1 plus or minus, this 4 you can take that out. So root of 4 is 2 omega 1 square by omega 2 square divided by 2. So the final equation will be alpha is equal to, you can cancel all the 2's in here, therefore it will be minus omega 1 plus or minus root of omega 1 square minus omega 2 square. Now you can separately write alpha. Let's take that root as alpha 1 and an alpha 2. So alpha 1 will be omega 1 plus root of omega 1 square minus omega 2 square, and alpha 2 will be minus omega 1, minus omega 1 minus root of omega 1 square minus omega 2 square. Clear. Now the solution will be of the form. The solution is actually x at a particular time, x of t is equal to a1, it is of the form a1 e raised to alpha 1 t plus a2 e raised to alpha 2 t, where a1 and a2 are some constants. So this is equal to a1 e raised to alpha 1 is minus omega 1 plus root of omega 1 square minus omega 2 square t plus, I just erase this side, plus a2 times e raised to alpha 2 is minus omega 1 minus root of omega 1 square minus omega 2 square t. Clear. So this can be written as a1 e raised to, you can separately write this e, so e raised to minus omega 1 t into e raised to root of omega 1 square minus omega 2 square t plus a2 into, here also it is e raised to minus omega 1 t into e raised to minus root of omega 1 square minus omega 2 square t. Here you can take this e raised to minus omega 1 t constant, therefore x of t is equal to e raised to minus omega 1 t into a1 e raised to root of omega 1 square minus omega 2 square t plus a2 e raised to minus root of omega 1 square minus omega 2 square t. Clear? So this is the final expression. Now we can also simplify this as, again let's assume two factors. Let a1 is equal to some half times a e raised to I theta. Also a2 is equal to half a e raised to minus I theta, where I is the complex number. Also let's assume omega 1 omega 2 square minus omega 1 square is equal to some omega 0 square. Remember, omega 2 square minus omega 1 square is omega 0 square. So this is equal to x of t is equal to e raised to minus omega 1 t into a1 is half a e raised to I theta into e raised to, see this is omega 1 square minus omega 2 square. So this root. So this is equal to root of minus omega 2 square minus omega 1 square. This is equal to root of minus 1 into root of omega 2 square minus omega 1 square. So I'm just writing the power of e here. So my minus root of minus 1 is I. This one is equal to root of omega 0 square. So it is equal to I omega 0. So this is equal to I omega 0, then this t. Plus this is equal to half a e raised to I theta. This one you only need to change, you only need to put a minus in here. So this is equal to minus, here a equal to e raised to minus I theta, since a2 is equal to half a e raised to I theta into e raised to minus I omega 0 t. Clear? So this is equal to x of t is equal to e raised to minus omega 1 t into this is equal to a by 2 e raised to, this can be written as omega 0 t plus theta, in outside the bracket it is I, clear, I is common, plus a by 2 e raised to, here minus I is common, inside the bracket it is omega 0 t plus theta, clear. So this is equal to x of t is equal to, this a by 2 can be taken out, a by 2 e raised to minus omega 1 t into e raised to I omega 0 t plus theta plus e raised to minus I into omega 0 t plus theta. Clear? Now you know we have e raised to I times phi is equal to cos phi plus I sin phi. Similarly, e raised to minus I phi is equal to cos phi minus I sin phi. If you add these two equations, you have e raised to I phi plus e raised to minus I phi equal to, these two will get cancelled. So it is 2 cos phi. Clear? Here phi is equal to, here phi, this is the phi is equal to omega 0 t plus theta. So x of t will be a e raised to minus omega 1 t by 2 into this whole value will be 2 cos phi. Phi is omega 0 t plus theta. You can cancel this 2 and 2. So the expression for the displacement after time t is equal to a e raised to minus omega 1 t cos omega 0 t plus theta. Clear? This is the displacement of damped oscillator. Displacement of a damped oscillator after time t. Clear? Here this omega 0 is called, we have this omega 0. Omega 0 is the angular frequency. Angular frequency. We have omega 0 is equal to omega 2 square minus omega 1 square, omega 0 square. Therefore, omega 0 square, we know omega 2 square is equal to k by m minus omega 1 square is equal to b by 2m whole square. This is the first, we already took the values of omega 2 and omega 1 in the start of the derivation. So I just substitute those values in here. So omega 0 will be root of k by m minus b square divided by 4m square. So this is the angular frequency omega 0. Now you have the time period of oscillation. We have omega 0 is equal to 2 pi divided by t is equal to root of k by m minus b square divided by 4m square. So that gives time period t is equal to 2 pi divided by root of k by m minus b square divided by 4m square. So this is the expression for time period. And the frequency will be, the reciprocal of time period is the frequency. So frequency is equal to 1 by t, time period. that is f is equal to, you can take the reciprocal, that is 2 pi is equal to 1 by 2 pi root of k by m minus b square divided by 4m square. So this is the frequency. Now if you look at the displacement, you just take this equation again, that is we have let's take a time t2 greater than t1. Suppose t2 equal to 4 seconds and t1 equal to 1 second. Any time t2 greater than t1. We have omega 1 t2 greater than omega 1 t1, going by the inequality. Also e raised to omega 1 t2 greater than e raised to omega 1 t1. And if you take the reciprocal, which means 1 by e raised to omega 1 t2 will be less than 1 by e raised to omega 1 t1. That is e raised to minus omega 1 t2 less than e raised to minus omega 1 t1. So this is equal to this one. If you multiply cos omega 0 theta with both the terms, this will be e raised to omega 1 t2 cos omega 0 t plus theta less than e raised to minus omega 1 t1 cos omega 0 t plus theta. Now on the both side, if you multiply with a, here it is a, here it is a, which means this is x of t2, displacement after time t2 less than displacement after time t1, which means as the time progresses, the displacement reduces. So with the progress of the time, the displacement reduces. So the graph of the equation will be like this. Suppose the y-axis represent the displacement after time t, and the x-axis the time period. Suppose this is the maximum amplitude plus a, and this is the maximum amplitude in the opposite side. So at the start of the oscillation, the amplitude is maximum, and as the time progresses, its displacement reduces. Clear? And finally, it almost reaches 0. Clear? So the graph of the displacement will be like this.